Hello, everyone. Welcome back to stream number 14. I guess I need to start getting rid of the tag newbie streamer. I guess. I don't know. I don't know how it works. It does depend. When can you get that label off? After some specific number of live streams? Or is it maybe after accumulating some kind of community? That's a good question. I wonder how different people would take that. Yeah, welcome back. Today we'll try to do some more work on the CommonFS and OSFS. Mostly we want to do reading and writing, basically byte arrays. So reading from and writing to files. We'll see how we can get arrays instead of just strings like we did in last live stream, and we'll probably also touch on walking through directories, so that we can have that functionality completed as well. And when we take a look at byte arrays, I wonder if we'll need to touch on different subjects like, cursors and other stuff. We'll see how that goes. But before we start, first of all, like and subscribe if you like the content. You can comment during the live stream. You can comment after the live stream has been completed. I'll be always happy to answer questions. I'll read your suggestions, or, I'm always happy to engage with the community. So continuing, I kind of started this tradition that each live stream starts with going a little bit further to NIM tutorials. First 20-30 minutes. So let's switch to the browser and let's continue with that. So we're going through the official tutorials, tutorial part 1, and my notes say that we finish at var args. So let's go through var args. I believe, yeah, here they are. Funny thing is that today I actually chopped up video about var args from like one of the previous NIM by example tutorials that we went through. So it'll be interesting to see how this differs from that other tutorial. So here we go. var args. A var args parameter is like an open array parameter. However, it is also a means to implement passing a variable number of arguments to a procedure. The compiler converts the list of arguments to an array automatically. So we can basically define a proc like my write line. We give it a file, and then basically var args of string, which will be like an array of strings. So then we can iterate over those, over items of A. So var A is a list, so we get items of it. And yeah, we iterate over those. And we write each one of them to the file. And at the end of the file, we just add a new line, and we're done. So this way, we can basically call this proc by giving all those strings just comma separated, like they're separate arguments. But because this is the last argument, or whatever parameter they call it, it figures out, oh, this is just that, so it will be automatically transformed into this thing. So that's very handy. That's how we were using, for example, echo. This transformation is only done if the var args parameter is the last parameter in the procedure header. It is also possible to perform type conversions in this context. So that's the superpower of var args, that we can define it here. When define var args of string, we also say comma and give the name of the proc or operator or whatever that is supposed to be run on each of those parameters. So here we give it the $ operator. It has those backticks just so that we can kind of quote it, say that it's that name, and this continues like previously. But what it means is that we can write this. We can pass an integer, we can pass a float, we can still pass a string, but this operator will be, nym will try to call that operator for every single one of them. And in this case, it's, just like here. Because, this $ operator, which is like toString operator, is defined on all those types. It will be fine, and it will just convert them to strings. So this is, again, this is exactly how echo works when we, write to the console. In this example, $ is applied to any argument that is passed to the parameter a. Now that $ applied to strings is a no-op, as in, if we have this, compiler will figure out, what? This does nothing for strings, so it's just gonna discard it at the end. Okay, excuse me if I'll be a little bit slow today, but it's been a long day and I'm really, really tired. I need to kind of warm my brain up to start thinking again, which isn't easy at this very moment. Okay, so that's it when it comes to var args. That's not a lot, but it's very clear. It's not an in-depth feature. It's just very, very useful feature. And something similar exists for C#. You can do something similar in JavaScript, I think. I know there's a lot of types have that, and C# is called params or something, where again, things are converted into a list. Okay, let's continue to slices. Slices look similar to subranges. Types in syntax, or to subranges types in syntax, but are used in a different context. A slice is just an object of type slice, which contains two bounds, A and B. By itself, a slice is not very useful, but other collection types define operators which accept slice objects to define ranges. Okay, so we have two variables, just two different strings, and we can do echo A and give it the range, right, from 7 to 12. So we'll return a prog here. Bam. Okay. And then we have B from 11 to a character before the last one. So useful 11 use. Huh? This is wrong. Something wrong here. So 1, 2, 3, 4, 5, 6. Wait, 0, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 11 is basically from here, U, and then we go here and -1, -2. Useless instead of useful. Oh wait. This is E because we're assigning, okay? Then we have echo B. Slices are useful, all right? So in the previous example, slices are used to modify a part of a string. The slices bounds can hold any value supported by their type, but it is the proc using the slice object which defines what values are accepted. So it's up to B, whatever is assigning to B, or in this case, we have the B as a, sequence of characters that have defined the square brackets operator on them that accepts a slice, right? And that proc of that, that operator, it figures out what to do with those numbers, right? So that's that. So for sequence of character might work if you create your own type that, wraps a sequence of something else, you can make it work totally different. To understand the different ways of specifying the indices of strings, arrays, sequences, etc., it must be remembered that NIM uses zero-based indices. So the string B is of length 19, and two different ways of specifying the indices are. So we start, first one is 0, right? This one's 11, and this one's 17. While using the hat syntax, we just go from the back in the other direction. So we're B from 0 to hat 1. I'll be calling it -1, okay? Because that's some other languages uses negative and it's just easier to say. It's equivalent to B from 0 to length -1. So this is what you would be used to write when writing, C or some older languages. And this one, yeah. And it can be seen that the hat 1 provides a shorthand way of specifying the length of the sequence -1, basically last element. See the backwards index operator. Well, we learned about it already. In the above example, because the string ends in a period, to get the portion of the string that is useless and replace it with useful, yeah, exactly. We needed to go to what do you call it? Backwards 2. So B from 11 to backwards 2 is the portion useless. And B from 11 to backwards 2 is equals useful, replaces the useless portion with useful, giving the result statuses are useful. So notice that useless has 7 characters, while useful has 6. So we can just replace substring just like that with different length. Note 1. Alternate ways of writing this are, oh gosh, totally backwards way. Backwards 8 to backwards 2 equals useful. Or from 11 to length -2. Or 11 to length -1, but not including the last element. So yeah. These are a little bit less readable, I'd say. Note 2. As the backwards template returns a distinct int of type backwards index, we can have a last index constant defined as constant last index equals backwards 1, and later used as 0 to last index. You could have that, but why? Everyone writing NIM will understand this syntax. Ooh, what the hell just happened? Okay, so I guess that's it about the slices. I wonder if we can just try to do something with slices, like get actual type, right? So let's just grab that code. I want to observe it. So let's go to our code and paste it in, okay? We have it when we run it. Not this. Yeah, prog, and slices are useful. So that's fine. But what if we want to just, I don't know, have this whole thing as a variable? Can we do let some slice is, and we do 11 to backwards 2? Where's backwards? Backwards 2. Can we do that? Ah, it's an array of, array from 0 to 0, so array of 1 element, h slice. So that's some h slice. I guess I can do it without the square brackets. Oh, look at that. H slice, whatever h is, but some kind of slice that one is system integer and the other is system backwards index, but they're all kind of integer. Okay. And could I just put it here? Some slice? I can put it there. Why not? Can I do something about it? Let's change it to var and some slice dot. We have A and B. A is 8. Okay. So that'll be useful will be should be the result. Let's try to run it. Are A useful? Oh, wait, what? Some slice should be to this here. A was integer, so that's the left side. Oh, because normally it was 11. Okay, normally it was 11, so I'll do 12. I was looking at the wrong slice. And now it should be useful, right? There we go, W. Okay, so we can make those slices on the go, modify them as we go, do fun stuff with that. Yeah, I can see it as, let's say you're processing a string, you need to have some kind of area highlighted, and as you're working on it, maybe you're parsing some kind of format. Oh, there's this character. That means I need to expand my slice that much or move it or something of that sort. And this way you're just operating on a little slice instead of having two separate variables somewhere defined. And you can keep track of it and just pass it here without, with one variable. Bam, there you go. Okay, I can see it being very useful. And again, this is literally holding those two values. That's all it does. It doesn't do anything else. It just holds those two values. And I guess using that, one could easily define their own proc that takes it, right? Where was the code? Not this code. This one. Can I make something like a proc? Replace substring. Okay. And what we do is we take the var s, as this will be our string, right? We'll have whatever new as string. And then we're gonna do, instead of having start and length or something, we can do h slice, or is there slice? There is also slice. Wonder what's the slice versus h slice. Slice, wait, it will be the, yeah, call it slice. Type slice. Is just slice good enough? Or is that like generic? Oh, it needs t. So integer. Let's just do the implementation, okay? We replace it, so we take the s and we specify the slice inside of it is new, and this is all that function will do. And therefore here we could just do b dot replace substring, and we give it useful and some slice, okay? And this should replace that. The only thing is this ain't happy. Comma int. Nope. Because hslice worked that way. So what's going on? Syntax is parameter var t, not var parameter t. Oh, yep, I'm an idiot. There we go. And this doesn't have to be like that at all, right? It's just slice, and that should work. So B here. Expected 1, first mismatch. I wonder if it needs to be that crazy H slice or something. H slice. Now it's fine. Can I run it? And will it run it? Okay, it ran it. So I wonder what's the difference between slice and H slice. That's something that hasn't been explained, but curious. Okay, we'll figure it out one day. Let me get back to the tutorial. So we went through slices. Let's just touch on objects and maybe not tuples because they're a bit long. Let's just look at objects, and that'll be it for today. So objects. The default type to pack different values together in a single structure with a name is the object type. An object is a value type, which means that when an object is assigned to a new variable, all its components are copied as well. Each object type, foo, has a constructor, foo, and then we can specify the fields, where all of its fields can be initialized. Unspecified fields will get their default value. Okay, so we define type, which is a person, a named person, which is an object. And here, indented, we can specify the fields. We have name, which is a string, and age, which is integer. So then we have instance of that person, and we could specify those two values. And we can echo, and we can use the dot operator to get those fields. And we can create another person. Oh, person 2 is person 1. So suddenly, because these are an object is a value type, which is very important. It's unlike JavaScript, unlike classes in C#, they are value types. Therefore, here we basically copy the person 1 to person 2. Just like we had with an array. Everything's being copied. So if we do person2.age, we add 14 years to the age, suddenly person 1 and person 2 have two different ages because there was a copy here instead of, just a reference. And the order may be changed. When we're defining a person, we can define age and name first. It's because, they are labeled, so we can just mix and match, unlike in tuples. And not every member needs to be specified. So we can just specify age 3, and therefore the name will be default, and for string it's an empty string. So unspecified members will be initialized with their default values. In this case, it's an empty string. Yeah, so we can assert that, hey, person 4 name is, in fact, empty string. Object fields that should be visible from outside the defining module have to be marked with an asterisk. Yep, just like everything else. And not just the whole object, but also the fields themselves. This way you can have, an object that has, for example, name visible, but age not visible. And you could utilize it in some way. So some of the fields can be, considered private to the outside of the module. Okay, that's it when it comes to the tutorial. And let's get to the actual code of the CommonFS. So again, off stream I did few little things. So when we go to our CommonFS and we look at our to-do list, let's call it, what I implemented is the parent on a directory and parent on the file type. Where is it? Parent. Okay. In both cases, the parent will be always a directory. So we just return that directory. Although that's not entirely true. Let's go to CommonFS and look it up. So we go to file system, and then we have directory of file shared. And again, we can define exactly the same thing on both. So we define proc parent. We export it, of course. And it's defined on a directory or a file. Any of those can be handled the same. And what we're returning is an option of type directory. So this is basically a nullable, or I don't know, nillable, because nym has a nil type. So this is basically either returns a directory or a nil object where there's no directory. So the whole idea here is we can actually add the docs. Okay, I haven't done that somehow. Returns the parent directory of the directory or file. If the provided path is a root directory, it returns none. Okay, and none is basically that option here. So let's see how it's implemented. So we basically get the path, right? Path is self absolute path. If the path is root directory, we return none of the type directory. This is basically, this could be written like this, okay? So basically, if it's a root directory, there's no parent, right? So we shouldn't return anything. We shouldn't return another directory because we might have code that iterates over parent to walk backwards to the root or something. So in this case, when it's root, it returns none. While if there is something, if it's not root, we can do, hey, return some self file system. We get to the file system, get the handle of the directory, and we provide a path dot parent directory. So the path, because this is the type path, already provides a proc parent directory that will properly return the parent. And I think I'm missing a test here. We'll get to that in a second. So this way we can basically, return either something, like here, sum and value, or nothing. And now let's look at the tests for example, for the directory to see if we handle things properly, how we can handle the option type. Also, for option to be available, you need to import standard options, okay? It's in a standard library, so it's awesome. It's just not something available by default. So let's go to tests directory handle. Again, we import the options, and we can scroll not far. So here we have two tests, 1 and 2. So let's look at the latter first because it's a little bit simpler. So the parent should return none for root directory. So we basically create a path, which is a root directory, just a slash. So it's an absolute path that has nothing, it's root. Then we get a handle to the directory just by providing in that path. And then what we're doing is the parent option is the handle. We get the handle called the parent. So it should as return option directory. So there we go, option, CommonFS directory. And in this case, we are expecting that it should return none. So what we can do is call check if it's true. Parent option is none. So option allows us to call is none, and that will return true if the non object was returned. Similarly, there's is some, okay, that tells that hey, there was something returned, actually, not nothing, there was something. And then we could do get, and that will return the actual value. In this case, get will show what it inferred. It doesn't show what it inferred, but in this case, it should be a directory. If you call get and the type is none, it would just throw an error. So we basically check if it's none. And then we have other test. Parent should return the parent directory. So this is a little bit different. I started, some of those tests were getting a little long because I needed to test different things. Oh, we have a viewer on Twitch, for talks, as asking what mic am I using. I'm using Audio Technica. What was the model? AT2050. It's a condenser microphone with 3 different patterns, so just in case I can switch. Right now I have the forward, the uni, whatever. But if I wanted to, I know, have a conversation, record it with somebody, I can just have microphone on 2 sides or record from all around if I need to, I know, record something somewhere. So yeah, I wanted a microphone that's good for all around, not just for live streaming, but for music production, actually. So I hope that answers the question. Okay, getting back to our test. So what I did, I defined a like array of test cases. So it's an array. It starts and ends here. And it contains basically tuples of one path, which is like the directory path, and the expected parent, okay? So that's that. And what it does here is basically loops for all the test cases, right? The test case. And then it just, what it does, it takes the left side, the 0, and that's the path. And then expected parent path is the other side. Then we basically, just like before, we create a handle. We try to get the parent as an option. And in this case, we're checking if it's sum, because it should be saying true to is sum. And then, if that passes, we're going to the next one where we get that option. We get the value out of it, which is a path. Is a directory. And from the directory, we can request an absolute path. And we're just checking if it's what we were expecting. So that runs through everything. And that brings me to one thing that I think I missed, because, we're checking like, hey, if we're going to give this directory, right? We're basically in directory there. The parent will be somewhere. So the return should be temporary somewhere. Same thing here, because we're testing directories. We created a directory, so in theory, manifesto.pdf could be a directory. Just the fact that it has .pdf doesn't mean it's a file. We treat it as the directory, so it should return user as the parent directory. And then we continue with the same. It's just we have a edge case where we have a file that starts with a dot, or we end with a slash. So these are kind of futile, because we're using paths from nim. But just in case something goes weird someplace, we want to make sure that when we pass this, it should still work. Okay. But one thing that we're not checking is, what if I'm going to add another case? Let's just try to run it first to make sure that still works. Nimble test. Ooh, test. Okay. And everything for file, parent should return, and this, they're all okay. And for the directory, both pass as well. So let's add that one case I just thought about. It will be, what if we're going to give it something like, bin, and therefore a parent should be a root directory. Will we actually get that? That's the thing that I don't know. So let's save it, and just like that, it'll iterate over those. So, we don't need to add 15 more lines just to have that other edge case. And let's run it. Run test task. Okay, looks like it worked. Okay, so our magic, whatever was the implementation, our magical path.parent directory handles that perfectly. Thank you, nim standard library. It's awesome. So that's great. Okay. And yeah, so that's what I did for the directory. And we have the same thing for files. We have those two, so we can add that extra edge case just in case as well. So let's make it, I don't know, home or whatever. And it should still work. There we go. All tests passed. So that's that. And let me push those changes then. Just by walking you through the changes that I made, we already found some areas to improve, which is always awesome. Okay, so this would be CommonFS. And let's make sure that improve docs and testing for getting directory/file parent. Okay. And let's push it. So that's that. And did I change anything else other than introduce this kind of looping test? In this place, I don't remember if I updated any other tests. But that's pretty much it. Nothing else happened. I also, when thinking about things, because, you know, today it would be nice to do something like read bytes and get an array of bytes or whatever, or write bytes to a file. I realized that, you know, after that, it would be nice to implement something more like reading like buffers out of the file, because let's say we want to do something in little batches, I don't know, low memory or whatever. Many reasons when you would prefer to read data from drive in little, you know, smaller buffers. Maybe you're processing them somewhere in chunks in a different thread, and you want to just send them while you're reading from the file to make things, you know, a little bit more optimized. Many reasons. But for that, we will suddenly need something like cursors for reading and writing files, so that we can actually, you know, skip something and whatnot, just to get up functionality. And then whoever's implementing the, you know, work on the implementation will need to make sure that this is supported, you know, to pass all the tests. And I think for some situations, I don't know, maybe, I don't know if it's true, but with S3 bucket, or maybe with something like SFTP, you wouldn't be able to load just part of a file. Maybe it would be necessary to download the whole file, hold it in memory or somewhere in temporary storage, and read from file at that point. I don't know, but that will be up to whoever's making, you know, that implementation. But working with cursors should be implemented, definitely. So that's that. And I think this will be very closely related to making everything async. So that will make us actually go over all the things that we implemented and make sure that there are async methods, so we can await them and maybe not optimize them for async yet, just pretend that they work that way. But in the future, especially when we're going with some, you know, reading buffers and whatnot, this whole async thing will work well. Okay, so let's actually start implementing, because I'm blabbing just about nothing. Let's try to work with this read bytes. Let's think how to implement that. So we can go to our CommonFS and make text a bit smaller, as we're not presenting, now we're actually coding. So this will be definitely inside our file system, where we have read all and then we have write. So let's continue here with read. I can make it a bit larger, yeah. So let's write something simple. Proc read, and we had it named as bytes, okay? Read bytes. So let's make a first one where we're basically making it, you know, work on a file system. We can just copy the whole thing, and we are expecting a path. And as a return, yeah, sequence of bytes. Let's make it that simple. We don't know what size of it is, so we can't return array because we need to already specify what size of an array it is. But in our case, it's a sequence of bytes, so it could be whatever length. We're just returning bytes, okay? And you know, we'll do the same thing here. We just get the path and just do self read bytes implementation because we're expecting that, right? And we'll give it absolute path, and that's all we're doing basically. So we also need a similar one, method read bytes implementation, and return sequence of bytes, raises the same stuff. I don't care right now, and there was an exception, okay? So that's that. And what is this unhappy about? Method needs a parameter that has an object type. It has, so we ignore that error right now. So we have our read bytes. Everything here is the same. So we can just add some docs, and I just learned that you don't need this thing here. This is, you know, not necessary. All the standard documentation just like that. So reads the content of the file at a specific path and returns it as a sequence of bytes. That's it. If the file doesn't exist, it raises the file system error. So just as that simple. So, gosh, this is angry about everything. Whatever. It's num-suggest. It freaks out at anything to do with methods, I guess. Okay. So let's implement that, okay? Or let's actually test it first, just like we did previously. So in our source, CommonFS, we go private and we'll create new file. Test read bytes, okay? We'll be testing it here. And let's copy some other tests so that we have something to copy paste because I am not typing everything. So just like previously, we go here and grab everything all the way the first word test. And let's paste it. Verify read bytes implementation. That will be our suite of tests. And then implementation read bytes. And also here read bytes tests. Okay, we might rename those at some point because I don't like the read all and then read bytes. How about read string or something? I don't know. Don't like that naming personally. Okay, we create stuff here, remove it. It's all good. So the first test, and now it will be should read full contents of a file via absolute path. Let's do that. Bam. And yeah, let's just copy it for now because it should be exactly the same code. The only thing that will be different is the, you know, returned value. So I guess we'll need to get the result in some way to verify that the whole thing is an actual, you know, proper thing with bytes. Let's think about it. So we have our text file 1, get absolute path, let's call it hello world, whatever. Then we just write the files so that we have proper contents. And then what we should have is, instead of read all, we should have read bytes, right? We provide it with the absolute path equals, and right now the text that shouldn't equal because this is string while this is basically a sequence of bytes. In theory, bytes could be turned into characters, so it's kind of the same thing, but you know, let's start with that. And then we have the same thing when we get a file and we want to do read bytes on the file itself. So before we do that, let's just fix that and grab this whole thing and we'll just put it on a file operations, read all, and we have proc read bytes. We don't need to provide a path here, a sequence of bytes, and itchy today. Reads the contents of the file. We don't need to add the specified path because we already have this file. And yeah, all we do is basically self.fs.readBytes, and that's it. And it shouldn't be a problem. Yep, let's ignore it. Okay, so let's get back to our test. This should be fine now. So the only thing that we don't have is we're comparing string to a sequence of bytes. And that's not necessarily the best thing. Because the thing with strings and nim is that they are zero terminated, whatever. So some of those symbols, like in between here in practice when working with bytes, it could be just, you know, zero, just a bunch of zeros. Therefore, nim would think that this is where string ends. I presume, I'm not 100% sure. That's what I think would happen. So we need to think more of a, hey, this should be an array of bytes. And I don't know if we have something like 2 bytes. Does that work? Let's see. Let's try to run tests and see how it fails. Bam, invalid indentation. And that's in CommonFS 129. Always those pesky errors. 129. All the way here. Without indentation. So that means we forgot a parenthesis here. There we go. Save. And let's rerun the tests. Okay, we've got another exception. Undeclared FS, or like here, indentation one. No, that's not it. Let's, yeah, number test. 219. Okay. 219. FS doesn't exist. Let's see. 219. Oh, not file system, sub-file. There we go. So that was another bad thing. And now, oh, it worked. So we should have tests for that. Oh, we didn't run those tests yet. Yet another thing to remember. In test.nim, we need to include it. So we do import private test read bytes. And we can just, let's actually place it here under the read all. And verify read bytes implementation. There we go. Now when we run tests, it should actually go through it. And looks like it completed. Where did it run it? Oh, I'm not even running the correct tests. Sorry, I'm really, something flying here. I'm really tired today. So yeah, instead of running tests here, obviously I need to do nimble dev install. This will install this version of the package. Now we can switch to the OSFS, where we need to first quickly go to our OSFS and we implement method read bytes implementation. We basically should have the same thing. Just return the sequence of bytes, okay? So suddenly the read file won't work. We need to find something that will be reading the bytes, and that read bytes, that name comes from the standard library, because initially we did the research, so I should be, in theory, able to just go here and go standard library and to read bytes. Can I search for that? Let's search it. There we go. Sync.io proc read bytes. This just start and. Do we have any other one? Looks like that's the only read bytes. Okay. Read bytes reads length bytes into the buffer A, starting at A start. Returns the actual number of bytes that have been read, which may be less than length. If not as many bytes remaining, but not greater. So we need to import sync.io, and let's just copy this whole thing. And we can do it, right? We can do it. So I'll just, let's do here, import, like from sync std / sync.io, import read bytes. Okay, that's what we care about. So if we paste it here, okay, let's scroll to the left, and let's just put this as a comment. We don't need all that. We know that read bytes takes a file. Oh, okay. I see. We'll need to open a file first. So I'll get the file. Right. Sync.io. Do we have open somewhere here? Close, and we should have open. Here's a file from a file handle. We've given mode. We have also our file name and mode. Okay. And some buffer sizes. And then we have one, we did the same thing, and it returns a file. Okay, so let's use that one. So again, we're gonna, from this, import this and open and close, I guess. So first will be let file is open, and we do the absolute path with string and fm read, right? Comma. Thinking. Mode. What is the mode? fm read, read write existing, and append. So it will be fm read. All we do is read here, okay? So we open it. Oh, why do I put a semicolon? Can raise an unlisted exception. We'll get there. Let's just put in a try, and whatever happens, we'll catch it. Okay. So we get a file, and if we open, we need to defer, and we close the file. That's the most important thing. The defer keyword basically says, okay, after you're done with all that, before you exit out of the try, make sure you close the file. Okay. So we have that done. Okay, so now we have the file. So we should be able to just give it the file. We'll just do let bytes is read bytes, the file. Then it wants an open array that will be modifying. Okay, so this is what we'll be writing to, and then from start to length. Oh, so this is like the cursor from when we start and end. Ugh. I don't like dealing with files like that, but hey, it shouldn't be that hard. So let's make it var, and we do a buffer, okay. And that will be, I'll make an array. I guess buffer will be array of, how many bytes do we do? I don't know what is the good. Let's do 1024 as a start, and that'll be byte, okay? That's how many values we can hold. And this will be our buffer. And I presume it already has the default value initially. And we should be able to just put it in here, right? Into open array. So we do that. A will be int 8. So yeah, that's a byte, I presume. So we just do buffer and accept it. File, comma, buffer. That will be start and length. So this is somewhere where we'll need to iterate over. So let's make it constant. Buffer size is 1024. Because it's a constant, we can just shove it here. And then we're gonna do result. It will be a sequence of bytes. Perfect. Let's do this byte to it. It should work. Byte is basically the equivalent of an 8, right? So it should work. So buffer result, and then we have var cursor, and that'll be a natural. And we start from 0. Okay, so that'll be our cursor, and then we can do basically while sure, while true. What we can do, let's see what Copilot wrote for us. We basically bytes read. Yeah, so we call read bytes on a file. We give it a buffer. We start from 0. We want to use our cursor here. And we want to load that many characters, right? Because I guess it doesn't care what the size of the buffer is. So that's that. And it should return the integer. So basically, reads len bytes into the buffer. It's starting at here. Returns the actual number of bytes that have been read, which may be different length. Okay, so that's good. So we just read the bytes, and we know how many bytes we did. The buffer is updated. So if bytes is 0 break, no, that's not what we want to do. First of all, so what we should do is, how would you do it? We want to get the result, okay, because of our sequence of bytes, add, and then we do buffer, and we start from 0 and go over to the number of bytes that we read. We found that the last number, right? Because this is length, so we do this. And therefore, we basically add however many bytes we read into the result. So if bytes read is not equal to the buffer size, as in we didn't get the whole buffer, we got less, that means that, hey, we reached the end of the file. Okay, so we can break out of this loop. So that's that part. And we don't add a result here. What we're doing is we just need to remember to increase the cursor by the number of bytes that we read. In theory, we should just increase it by the buffer size. Okay, that's all. And yeah, so this is basically, we can call it read the file in chunks to buffer in chunks and to the result. Okay, so we did that and we just finished, so we don't need any of that. Yeah, we're at a sequence. We can just finish here because this goes into results. Oh, not var. Can we do result? Is already a sequence, so we can get rid of this whole thing. Awesome. Okay, we close the file, everything. Yeah, that's it. We just return a sequence of bytes. And we have this whole thing wrapped in a try catch, so if there was an IO error when reading bytes, we'll just return it. And that's it. That should work, the read bytes implementation. Okay, if that's gonna work, I'll be very happy. So, read bytes implementation, and now when we test here, it should already run the tests that were implemented somewhere else. Okay, first failed. There's no 2 bytes, so I was right. So back in here in the in our CommonFS, there's the problem of our test read bytes. There's no such thing as 2 bytes. So let's think how to do it. We could quickly make a loop where we loop through the string and just get the, characters or whatever. And I believe we can do it within an assignment, right? Because we can do equals 4 and we do character in hello world, right? And we just do it like this. Can we actually do that? And what we do is basically, no, we can't do that because we would need a buffer. I think we have there's documentation for that. I'm sure. I think it's in the manual. And we can do for expression. It must be here. I recall perusing through those things. The relations overloading, semantic expression. If there's no for expression, no. There's block expression. We could use that, sure. Block, bam. And we basically say that let sure, result is sequence of bytes, right? And that will be just netted sequence. And then we go over the characters and we just get an ordinal value of it. Right? What does ordinal return? Let by whatever single byte character ordinal. We should be able to call that, and it won't tell us what type it is. We should add single byte. Something ain't have here. Character ordinal. Again, let's look at our docs, and I believe we should be able to go away. Let's just edit it, go to overall docs, and in one of those tutorials, we went through characters, and there was, they mentioned the ways of converting it. Characters cannot be mixed with integers. To get the ordinal value of a character, use the ordinal proc. Okay, so that should be it. But why isn't it? Can I quickly check here? Not in here, but in here. Now, quick fun, we can make a little test. Let's say that we have that character is A, okay? And let value is character dot ordinal, okay? That says is integer, but what if I want it to be byte? It's not happy. This might go int, but expected byte, which is uint8. Oh, okay, I see. Okay, so byte is literally uint8, not int8, so that was my bad, thinking that will be the same. So that means I could do dot byte. Just, yeah. Could work because we know that it's never gonna be negative or something. So, okay. So we fixed that mystery. So we just do this dot byte, byte. We get rid of this, and we should be able to add those to the result. And all we do is basically result to return it. Still unhappy about that, but we'll see if that works. And this should basically give us the bytes. What do you think? Is this gonna work? Let's reinstall it and see what the hell happens when we try to run the test. Bam! Exceptions. Result is immutable, not var. Really? Am I that dumb? Let result, of course. Var result. Silly me. Okay, that works. We have bytes everywhere, so that should be good. Let's just quickly inspect our implementation of it here, because are we using bytes everywhere? For sure. We return bytes. And we go over those things everywhere we specify bytes. Bytes red. And yeah. Result add. Buffer from here to here. Okay. And blah, 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 blah. Yeah, I think that should work. So I need to install this one. And going back here, I can run it and huh? It worked? Have read all, read bytes. Yes, it read everything correctly. So we wrote text file and we read it and it worked. Okay, I am very happy. Okay, that's a big progress. So we have implementation that works for that one test. We actually read bytes from the file, like all the bytes. And I guess we could also do read bytes and provide the same interface where we need to provide a cursor and how much we read and all that stuff. But hey, this is a little success, so that's very awesome. Let's just make sure that we don't have any other edge cases, which is the boring stuff, writing tests, right? So test read bytes. So the first one, that should read full contents of a file via absolute path. Right now we have this ugly thing. Can we make a quick proc that will just convert text to bytes? I guess. So let's do here proc string, like 2 bytes, okay. And we just do text string, and we return a sequence of bytes. and we don't even need to specify anything about the result because it already exists. Just do this, return the result. We don't need to return the results even. Okay, that's it. Wow. It's the magic of NIM. Skip everything. And therefore we can do the text is hello world 2 bytes. There we go. Save. And just to make sure, let's install the new version and let's run tests here. Okay. It works. So that's good. That means we can just go over things a bit quicker. So should read full contents of a file via absolute path. So we need to do the same thing via relative path. Ugh. So let's just copy it. One day I'm gonna change it up to make sure that we don't have to do that anymore. Text file 2, and this will be like whatever. This doesn't matter. Okay. And then we write it to the file, and then we basically need to do the file system. Current directory is the test directory, and therefore when we read bytes we can do a relative path relative, and the same thing goes here because we provide relative path when creating a handle, and that should be it. Save, install, go to OSFS and run test tasks. Okay, both work. So yeah, we basically need to include more test cases of other, weird edge cases. I'm gonna take a short bathroom break, so I encourage you to think what we should test and write in the chat if you wish so. Be right back. Alrighty, I'm back. And whoever was watching before is still watching, so that's awesome. But we don't have suggestions for tests to write, but it's okay. I just thought that, for testing, we quickly wrote that 2 bytes, right? Which I don't want to export. But I'm sure there's something in a standard library that already does it because, it's like really, that's the most basic functionality. But I'll look for it some other time and probably off the stream. For now, we know that we're reading it. We will need to check for a situation where the file is empty and when the file doesn't exist to make sure that, everything is fine still. So let's just read all on the side because it's pretty much the same thing, and we can just implement the rest of the tests. So this should go relatively fast. I'm just gonna add myself to do here. To do test reading contents of reading binary files, right? Because that will be the whole idea with the 0 character, something like that. Okay, just to make sure that we're gonna test it. So we've got those 2, and then what we via relative path should return empty string for file, right? So test should return empty sequence for empty file. So we have that text file 3. Okay, we've got that. We don't even bother what's inside. We write the file. We just write empty sequence. Okay. And we check when we read it that it's an empty sequence. And the same thing here. Hey, Copilot just wrote the test for us. And the next one will be should throw error if the file does not exist. Okay. So test should throw error if file does not exist. And yeah, we have next file. We don't. Yeah, we have the absolute and not check throws. Expect catchable error. For now, everything will be catchable error. And we do discard read bytes from the absolute path. Okay. And the same thing should be here. It's just we need to get the let file is get fs get file handle. Okay, we got the file, and we can do file read bytes, and that should throw an exception as well. Okay. There are tests. I have an extra one here. Should throw error if path points to a directory. Oh, of course. That's another important one because we want to make sure that those tests are being done, and the implementation of the library will always check for edge cases, especially that those edge cases might behave very differently depending on what the backend will be. So should throw error if file is a directory. There we go. And we basically do let's just copy this thing for now, okay? Copy paste. Okay, some directory, blah 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 blah. We check if it exists, and then we expect when we do read bytes the absolute path to an error, and the same thing here. Okay, we can just I had to figure out how to properly make it so that it's readable. Should I always put those? Should I skip them? Which syntax is like preferred? I need to work it out so I have consistent thing. Because there's this thing about nim, it has so much flexibility on how we call different, procedures and stuff that sometimes it might be hard to read because you can read bytes, right? It's gonna work, it's gonna call it. But at this point, you don't know if it's a proc or it's some kind of field or file. Sometimes it might be handy because maybe it's just a getter for something. But, gray area, I'd say. Okay, we've got all those tests. Let's just install it. Okay, and go to OSFS and let's run those tests. Error, cannot infer the type of the sequence. Of course we can't. So it'll be 54 and read bytes. That's what I thought was gonna happen. 54. There we go, read bytes is equal, and we have this problem here. So let's say that empty bytes is a sequence of byte, and it's gonna be like this. And therefore we can compare it here, and we can compare it here. And yeah, hopefully that's it. We don't have any comparisons with empty stuff anywhere else, so let's install it and run tests again, and more errors. Should override instead of appending. Execution external program. Test implementation. Suddenly writing failed. If I write it again. Huh. We have the same problem. But it happened earlier, okay? Should read full contents of a file via relative path. Oh. Let's clear it and run the test again. Okay. So it's clear that there's some problem somewhere here. Failed. Should return empty sequence for empty file. And then index out of bounds. The container is empty. So what threw that? Sync IO. Read bytes 53. Test read bytes 53. Okay, so right now write file is just unhappy. Isn't write file just like string or something? I should just do this. Or I can just touch it, right? I can just do whatever I did in a few other areas. And I can just create a file. Okay. So we'll do literally this line. Bam. And we can get rid of this one then. Okay. Yep, there we go. We found a workaround. Install it and let's run tests again. And let's hope it works now. Oh, all tests pass. Okay, so we fixed our errors. Everything works. Bam. So if that's the case, I'm very happy to go to CommonFS. Wait, the README. README. Okay. We have read bytes, we can check it off. I just want to. That's not it. Read bytes, and that'll be the sequence of bytes. Okay. And then we'll need to still implement the proc read bytes, and it returns int. But we'll do just the what would it be? Path, comma, buffer, and start length, I guess, for the buffer. Okay. So we will do that at some point later. And we'll have the same thing for write, where we have maybe not the, I guess, buffer to write, right? And then where we want to point it at, I guess. We'll see. We write bytes. Well, this will be sequence of byte. That's it. Well, we'll figure it out. So we made that one. Also on a file, we have the read bytes implemented. Let's just copy this thing here. So we have that one implemented, and we still need this one to implement at some point. What time is it? Whoa, it's getting late already. Time flies today. Okay, this will be a thing to implement. But okay, we have that for now, so that's good. And let's commit it. Okay, for CommonFS will be add read bytes all. Okay, so that will be that. We push it, and in OSFS we can basically say this thing delete implement read bytes. And this will be all. Okay, and we push it. Okay, I can see that Ben Davis is writing on YouTube. Sorry for reading it 4 minutes late. Okay, Ben Davis is asking, do you have any tests to validate if you are writing to an actual file? Maybe have a way to tell if you are writing to a text file or another format. If I can you have it print out contents in debug mode before and after the write method? At least the error should show the contents that were found if incorrect. And then he said, nice work. Thank you. So let me actually verify if we're writing everything properly. So in our CommonFS, we go to the read bytes. And what will we use to write stuff? With the write file, okay? So write file, this is a function straight from the NIM standard library. I trust it personally. We actually use the same thing all throughout other tests, and everything seems to check out, so I would personally trust it. And also, we read the data right after, so if nothing will be written, nothing should be returned, in theory, especially that this has no idea about the contents of what we were writing. So I'd say we're good. And with this, when we create a file and we are making sure that there's nothing in there, the file system create file is another thing that the create file is being tested already. So I could easily go to create file name, and we have a bunch of tests for testing if it actually works. So yeah, definitely we need to make sure that we're actually testing the creation. Ben Davis says, in retrospect, it sounds. I don't know. This is the YouTube chat has permanent heart that prevents me from reading stuff. In retrospect, it sounds more critical than intended. Haha. Yeah, I'm coming to this late, but bytes and strings are not necessarily the same things all the time. I agree, they're not necessarily the same things all the time. So maybe we actually add that tests, because I added the to-do that I thought maybe I'll do off stream, but we have only half an hour and I don't feel like dealing with writing right now because I'm really sleepy. It's you know, in half an hour will be 1 a.m. for me, and it was a long day. So the idea was to test also binary. Doesn't have typing validation. What do you mean by typing validation? Test reading binary files. So let's make it that we should read contents of this and that. Let's make it should read full string contents. Okay, we'll just make the string, and we're gonna add another test. Test should read full binary contents of a file, and we'll just go do the absolute in the meantime. So let's see. Ben Davis is asking, does NIM have typing, as in bytes can be a type or primitive separate from strings, like in higher level languages like Python, JavaScript, etc. Yes, bytes are different as strings, kind of. So in NIM, a string is, you can consider it as a sequence of characters, because it's very similar to how C is, like C language also considers, strings to be just sequences, or they call it probably whatever, arrays of characters. So each character is its own type character, okay? And what we were doing here at some point when we were doing the string to bytes, okay, we want to return a sequence of bytes. So what we're doing, we can iterate over string, and it will basically return characters. So each character here is of type character. And that character has, you can call ORD as ordinal on it, and will return the ordinal as like numeric value for a character. And in that case, that'll be an integer. Although in case of characters, this will be just, it's ASCII, so it's only from 0 to 255. So we can basically safely, explicitly convert it to a byte, which is translated to be a unsigned integer. Therefore, we're not losing anything here. The only thing is that strings and NIM are 0 terminated. So I guess there's a 0 character, and literally with the value of 0, that will be interpreted as the end of the string. I haven't tried it yet, but I wonder if it's possible to figure out if it's actually treating like that, or maybe NIM is smart enough and it will actually, do something about it. But we can write a separate test that will just straight up generate random binary data. We'll make sure that it has some zeros here and there, and just go for it. So what were we doing? Errors. Well, it should read full binary contents of a file. Okay, so we'll basically make a binary file. So we're not doing anything like that. Binary, it won't be 2 bytes anymore. I want to make it a nice sequence of something, okay? So binary is basically a sequence of byte, okay? And let's make it an empty sequence for now. We'll start empty. And we can basically go from 0 to 255. And let's just make it variable. And we'll basically add all those bytes to it, okay? Just let's make sure to do the bytes, okay? So we can basically write that. And yellow, we basically test for all of them with 0 at the beginning. We could actually make it double. So at the end, to double it, let's do binary, add, and binary, okay? Oops, can we add the whole thing? I think we can add the, yeah, add will work also for the whole sequence, so we'll concatenate sequences. So now, at this point, binary is all the characters from 0 to 255 twice. So we can make sure that if there were any characters that were terminating something in between, they won't be interpreted as a string, they will just go for it. And the write file, let's check documentation for write file. The write file, I believe, is from just a standard, the default thing that's being imported. So let's just make sure we go to all the way here, standard library. We can go to the system. And we have write file. A write file here. Okay. So either give it a string or contents will be open array of bytes, which accepts a sequence of bytes. So we can just, you know, if we call write file, we give it a path and give it a binary, which is a sequence of bytes, it will just write a sequence, okay? It's that simple. So given that, we create a file. And we just need to make sure that when we read bytes, again, it's exactly the same as binary. We can even do something like let read bytes. We just read it, and we can do the check read bytes dot length is the same as length of binary. Just in case, I don't know, fancy if you want to, whatever. And this will also call the whole thing there. That's all it is. It's like copy paste test, but it should test for binary files. So maybe that will tell us if we did something wrong. But I think it's gonna work. I hope. So we go to our OSFS and we run those tests now. And hey, all passed. If we go to read bytes, should read full binary contents of a file. It worked. All the values that we could create for each byte were tested twice. So hey, it works. So hey, we checked off another box. That means I need to create another commit, because I guess I committed everything without testing for those binary things. So test binary files with read bytes. Okay. And we just commit it, push it. And the magical thing is that OSFS hasn't changed, because all those tests that test the implementation of our OSFS exist in the common library. So I don't know if you're still there, Ben Davis. If you're still there, the whole idea is that we have CommonFS library in which we define all those things that we can call, like remove file, read bytes, and whatnot. I'm showing the wrong thing. So in CommonFS, we have like read all, getting the name of a file, writing, What else do we have? Checking if file exists. All those are defined here and how to call them. And then we have a separate library, in our case it's OSFS, which provides implementations of how to actually read all the bytes, how to do this and that and that. And what that means is that later, after we finish, roughly what the shape of the CommonFS is, and we'll have the OSFS working, we'll make in-memory FS as an in-memory file system, which will be a completely separate implementation of CommonFS that instead of dealing with real files, it will hold everything in memory, just so that when I'm making some other application, I can, write the code, during application working, it will use OSFS, but for tests, because that application will do a bunch of stuff with files, I can run tests with the in-memory implementation, and therefore I can have exactly the same code executing to, different backends or files, and therefore my tests won't be wearing off hard drives. They will be a little bit faster when, running in GitHub or whatnot, and I can have thousands of complicated tests of moving files, directories, doing weird stuff, and it should work. And on top of that, nothing would prevent somebody from making implementation interface to, let's say, use SFTP or access to S3 buckets or who knows what else. So you can have, the same way of accessing the files, no matter if they're on a hard drive, in memory, in S3 bucket, on an SFTP server, or I don't know, over SSH or something. That's the whole idea of that. But if it says agreed, if it's standard library, then I would trust it. But cool to test while learning to see what it's doing under the hood and learn how to predict its behavior a little better. Absolutely. And the other thing is that with this CommonFS, I'm trying to have all those calls as close to what standard library in NIM is doing, because I want this, my library to feel as if you were, if you know the standard library of NIM, you can easily switch to this one and not be like confused. Does it work like this? Does it work like that? Return some kind of error in the same situation. So let's say if you create a directory, it will automatically create all the directories in between that were missing, because that's what the standard library is doing. And therefore, I want it to work in the same way. So that's that. It's a fun little project that I actually want to use personally. So let's call it a day with working on CommonFS for today. In the meantime, I can mention that I actually managed to make the NIM for Unreal Engine plugin work in Unreal Engine, not just from a template, but I can create my own project and then add NIM to that. So possibly over the weekend or sometime I will start also streaming my adventures of trying to learn Unreal Engine and use NIM inside of it to write code. Let me actually show you something. Let me just make my screen disappear for a second, as you never know what's on the screen on live stream. I better not show it to everyone. NIM for Unreal Engine, that is it. So I just opened a project, which is this very simple file, game.nim. It lives in, and again I need to black out my screen. Okay, I don't have to. Cool. It lives in here. So I can open an Unreal Engine project, and inside of here I have set up NIM for Unreal Engine. So I can go in here and I have literally game.nim. And in this NIM file, this was already defined as an example of an Unreal Engine class, but what I did, I created an Unreal Engine class my math library, which is inheriting from Unreal Engine's U blueprint function library, and defines a function that is a blueprint callable, and it's a proc that takes two floats and returns a float and multiplies them. But what's cool about it that it's actually working with Unreal Engine. So if I'll go run the Unreal Engine, so bear with me for a second. It's gonna take a moment. Come on. And we go nim test 3. Of course, it's always opening the wrong screen. And there we go. So we have the Unreal Engine project running. And where did I place it? I opened the first person character. It's something that's at this point defined by C++ code. So, I have a mixture of both because I created a C++ project and then added nim to it. But what I can do is right click and do multiply. And I have my multiply here. It's super tiny right now on the screen, but this is the node I defined in nim. Okay? So I can do something add, and whatever. I can add 5 and 10. Okay? And when I compile it, it all works. When I play the project, it showed the number for a split second. Of course, it starts on a wrong screen. If I'll zoom the screen in, on the top left of the play area, it will show 50. Because that's the multiply, right? 5 times 10. If I would go suddenly to the code here, to the game, the thing is that I can make it, I don't know, let's sneakily make it times extra 10, okay? Because why not? I just saved it. I can run the task of compile game. It's thinking. And done. So when I go to Unreal Engine now, recompile it, and when I run it again, it shouldn't be 50 anymore. Now it's 500 on the top left. So, it works just like that. And there's nothing stopping me from creating a whole separate class or whatever. Of course, I need to figure out how to use the category. I can make another function like proc, I know, something silly. Stupid addition, okay? Whatever. It just added extra 10. There we go. I save it. I run the task of compilation. And it's pretty fast, right? And bam, completed. Took 6 seconds. Already here, I can do stupid addition, and then we have stupid addition. I can zoom in on that, hopefully, or something. Just like that, we have stupid addition, and everything works. So that's fun, and the crazy part is that we can do whatever in those methods inside nim. You can do looping, you can do whatever, you can actually do things with heap, like you can use sequences and everything, because garbage collection still works. And as long as you return proper, return values like, f vector or whatever, it should all work in here. You can define whole characters and whatnot. So I'm actually looking forward to it, to starting a series with Unreal Engine. I have an idea for a game with lots of experimental features. So it's, over ambitious, of course, but the way I look at it is that doing it on a live stream will force me to A, keep doing it because I need to, do the live streams. And B, keep learning and keep trying at it without giving up or, finding workarounds so that, I can learn something. And hey, combining NIM with Unreal Engine, that could be fun. I know that I want to do procedural world generation. I want to make some kind of like colony management, something like RimWorld, where I want to use some, some fun implementation of AI like Go Up or something, where the actors are somewhat smart instead of kind of dumb like in RimWorld. And twist on it is that it's from first person perspective. So instead of you seeing overview of everything from the top of whatever is going with your colony, you're actually inside of it. And you need to walk to different stations to manage tasks and whatever, what needs to happen and whatnot. So could be fun. Why not? Some project like that. And maybe even using ChatGPT to do some background, more interesting planning, or using it to generate some kind of events or whatnot. Who knows? It could be fun. So it's not to the idea is not to make an actual game. The idea is to have fun with Unreal Engine, of making games and see what happens. And learn them. So that's it from me. I'll be finishing for now because, like I mentioned, I'm tired. And I can switch to this screen. And hey, thank you for watching. I hope this was informative. And, well, I'll be continuing on Friday, where we will go over and probably implement writing and hopefully walking over directories. I'll see what I can do, before the live stream to see if I can maybe prep a few things, maybe already write some tests, because it feels like during live stream was like, most of it was just writing tests, and that's a little bit tedious, and we'll see. And I know that after that, I want to start making everything into async so that it's ready for whenever things will happen with over the network, as this will dictate a lot probably how the library looks and feels. So that's the plan for the next stream on Friday. And hey, thank you for watching. Like and subscribe if you enjoy the content. You can write in the chat also after the stream is finished. I'll be happy to, read the suggestions, respond to comments. You can ask questions, and links to the both CommonFS and OSFS are in the description of the live stream, so you can have fun with it as well. Thank you for watching, and till next time.